Okay, I thought I would just pick some miscellaneous problems here to work. Let's look at number 3, the park cleanup problem. We'll try to work odds just so you can actually see the answer key, and if you want to go back and work it and check it yourself without watching the video. It says your mathematics, this is on page 163, section 4.11, linear programming. Your mathematics club is arranged to earn some extra money by cleaning up Car Park. The City Recreation Department agrees to pay each old member $10, so old members get paid $10, and then new members get paid $8. That's kind of weird. I don't know why it would matter. You're working. The club did the same thing last year, so the old members are experienced. Well, there you go. Okay, so define the variables and write an equation expressing the dollars the club earns in terms of the members of old and the numbers of old and new members who work. So maybe we do something like let X be the number of old members. So let me put X here, and it's the number of old members. And remember, they're going to get paid $10 an hour, or $10, no, just $10. So if you got X of them working, the club's going to make $10 times X. And let's let Y be the new members. And so if you think about how much money the club's going to earn, they're not getting paid per hour, they're just getting paid a flat fee to go out and work. It would be $8 times the number of new members. Okay, so if we want to talk about how much money they earned, I'm going to use the same variables that the book answer key does just so that you'll be able to compare it more easily. The dollars, D is the dollars they earned. Sorry, I can't read that. Dollars earned. And so if I want to write an equation for that, I'll write that in red. D would be, how much do you earn? Well, $10 for every old member, and then you're going to get some more. And so you're going to add it in. You're going to get $8 for every old member. Remember, we've already defined those variables to be how many there are. I'll put a number on the number Y also, number of new members. Okay, now B. That was A. That's one equation, okay? B says, the following facts restrict the number of students who work. So ideally, this would be the money we get, but no, there's some things complicating the situation here. It's kind of what's happening. The number of old members is non-negative, and so is the number of new members. So we can write some equations for these, or some inequalities. If you think about it, we don't know how many old members there are. We called X the number of old members, but we know it's not negative. It could be 0, but it's not negative. So you would have to say, well, X is bigger than or equal to 0. And they also tell us the number of new members is non-negative. Okay, so that means there could be no new members show up, but you can't have negative people show up to clean a park. So we'd say, well, Y could be greater than or equal to 0. Okay, now this is the I part here. As I read, I may have to adjust these. I don't know, because this is what linear programming is writing a whole bunch of different equations, and then you go to a graph and you graph them all and you see where your solution areas are. Just like what we were doing in 4.10, it's just we're writing the equations, and there are going to be a ton of them, okay? 2 says, little II, the club has at most old members and at most 8 new members who can work. So not only is X bigger than 0, but X is also smaller. Actually, I already wrote that, so let me write X has actually got to be, at most, they're going to have 9 old members. X is the number of old members, so X is going to be less than or equal to 9. So right now, I kind of can change my equation on that one a little bit. I could say, well, X is between 0 and 9. There would be an equation I could use. So with this new piece of information, I'm putting it together with this old piece of information over here. But there's more, so let's see what else it says. At most 8 new members who can work. So we know the new members was Y. The most new members there are is 8, okay? Now, I know from over here that if Y could be 8, it could be less, but it's got to still be greater than 0, doesn't it? So these two facts I can put together and make a new equation. And that would be 0 less than or equal to Y less than or equal to 8. Now, even though I put those together, it's not going to be handy for me to do that in this case, because you think about this, this is a two-dimensional graphing system. That 0 less than or equal to x less than or equal to 9, that's a true statement. But it's not going to help me graph. It's kind of nice to think about it, but if I'm going to graph that, how do I do that on a coordinate system? I could use that to graph from. It might be easier, especially since, we're just trying to grab onto old things that we know, to use these equations right here. Because remember, all the x equals in this equation are going to be vertical lines, and the y equals are going to be horizontal lines. Well, I don't know. I got to think. Let me think about that a little bit as we go through this. We may have to. We're used to thinking x's as verticals, y's are horizontal. Let's see as we go through the equation what we're going to have to do. The problem is we got so many variables running around. How am I going to figure all this out? Well, let's write the equations first, then we'll talk about the other part in a minute. Let me go ahead and move to the next slide. One of these problems is kind of long because you got to figure all the part out. I may actually have to go to making 2 videos on this because of the time it's taken. Okay, so the little 3. The department will hire at least 6 students, but no more than 15. So let's think about this. They don't care whether they're old members or new members. But when I put the old and new members together, here's what I know. They will hire at least 6 students. So they'll hire 6 students. So that number can be 6. But it can't be bigger than 15. Couldn't I write something like that? Isn't this getting messy? Okay? What a messy thing we're having here. We got x's and y's, and we got x plus y's. We've got all kinds of weird equations, don't we? All right, so that takes care of that one. Let's look at IV here, 4. It says there must be at least 3 new members. Okay? Well, a while ago they told us, okay, so I guess the park department said, okay, we can't afford too many old members, so we've got to have at least 3 new members if we're going to hire, students. So y's got to be greater than or equal to 3. Well, that's weird. You'd have thought they would kind of, I don't know, they're just trying to really make this problem hard, just to be honest with you. And then, so that represents 4. Number 5 represents the number of new members must be at least a half of the old members. So new members was y. Y must be at least. So it could be bigger than this, but it can't be smaller than this, right? So the new members must be, I'll put a greater than or equal than, because it could be more than a half the number of old members. If I want to talk about a half the number of old members, wouldn't that be a half of x, right? Because x represents the old members, okay? The number of new members must be at least half the number of old members, but less than, okay, this really gets weird, less than 3 times the number of old members. Okay, so it could be bigger than a half x, but it has to be less than 3 times the number of old members. Is there a way to write that where it's a little easier? You might could say, okay, it must be at least half the number of old members. So it could be bigger than that or equal to that. But it's got to be less than 3 times the number of old members. So 3 times the number of old members was 3x. What I just did is put those 2 inequalities into one inequality. It gets really confusing because there's a lot going on here. These are our equations. So we wrote our inequalities, and now we're supposed to draw a graph of the system of inequalities. Now remember, as we go to this graph, we can't have half a person, can we? We can have only whole number of people. So I might shade a whole area, but I'm not going to count decimal parts. I'm going to be looking at whole number of people. We don't want to chop people up into fourths and halves to make them fit the requirements. So that's going to also be kind of weird. We're going to graph our equation the way that we've done before in section 4.10, but I'm only going to care about the numbers that fall right on the grid line because they represent whole people. We're not going to get all macabre here or anything. Okay. All right, so I'm going to go to a new video to graph that because this is just already a full video.